Welcome, everyone. It's a pleasure to be here, and a pleasure to be here talking to you today for our presentation, which is Moonshot Goals. So thank you for joining us. My name is Michael Aminzade. I work for VikingCloud. VikingCloud, we pride ourselves on being the company that brings security and compliance together.
And I'm Chelsea Lopez. I'm a risk director at FIS. FIS is a fintech leader providing solutions to financial institutions, businesses, and developers. We work with 95% of the world's leading banks and 50% of the world's most innovative companies. So when you think about FIS, anytime you buy a coffee, check your balance, or invest in your 401k, you're likely running on FIS software.
So why did we choose Moonshot Goals? Well, first of all, I'm going to take us back to the 12th of September, 1962. At Rice University, a guy that we may know, John F. Kennedy, or heard of, right, uttered some words that are now etched in history. We choose to go to the moon. We choose to go to the moon in this decade, not because it's easy, but because it is hard. Because that challenge is one that we are willing to accept, and one that we are unwilling to postpone, and one which we intend to win. Now, when this was set, they weren't entirely sure about how this was going to be achieved. They knew it was a huge undertaking, but they set the goal anyway. And I think we should just take a minute and listen to the words from John F. Kennedy himself.
But if I were to say, my fellow citizens, that we shall send to the moon 240,000 miles away from the control station in Houston, a giant rocket more than 300 feet tall, the length of this football field, made of new metal alloys, some of which have not yet been invented, capable of standing heat and stresses several times more than have ever been experienced, fitted together with a precision better than the finest watch, carrying all the equipment needed for propulsion, guidance, control, communications, food, and survival, on an untried mission to an unknown celestial body, and then return it safely to Earth, re-entering the atmosphere at speeds of over 25,000 miles per hour, causing heat about half that on the temperature of the sun, almost as hot as it is here today, and do all this, and do all this, and do it right, and do it first before this decade is out, then we must be bold.
Did you notice what JFK said at the end of the near impossible list of things that needed to be done to reach the goal of going to the moon? He said, we must be bold. Moonshot was born from this audacious ambition of going to the moon. And the term moonshot is defined as a monumental goal seeking groundbreaking results through innovative and daring approaches. That lofty aspiration was realized just 7 years after JFK's famous speech at Rice University. You may ask yourself, why revisit the past and the moonshot and the moon mission? And I would say because these pioneers, those pioneers, the NASA pioneers, dared to envision a future so distant that they could not see the path clearly, yet they had set strict goals to reach it. And like we said just momentarily ago, it was done within 7 years of that speech. If we don't set our own moonshot goals that drive innovation, we risk being surpassed by others who are setting their own ambitious agendas. Michael, do we have an example of a moonshot goal?
We do. And actually, we've got a few. But the first one I'm going to talk about is quantum computers. If we look at quantum computers, they have piqued the interest due to their capabilities and what they can potentially deliver for us as a society. Research out of the University of Washington, as well as the Lawrence Berkeley National Laboratory, demonstrates that scalable techniques that could one day enable simulations of fundamental physics experiments utilizing the scale of quantum computers based on a 127 quad-bit processor. They concluded that we may soon be able to use this quantum hardware to build these simulations that will be able to advance our understanding of particles that previously we could not even comprehend, right? Or we can see, and we will be able to find answers to some of the really challenging questions that we still have in life. If we now take that to certain technology roadmaps, we look at IBM's roadmap. They're aiming to reach 9 times that power by 2028 and 16 times that power by 2033. Still, we have challenges to resolve, but this is one of the main reasons why these items are moonshot goals. If we look at quantum computing as well, one of the elements about it, and it's a fascinating aspect I find, is around how two particles, when they're entangled, how they actually interact, and what this enables us to achieve. So from an entanglement perspective, when you've got two particles, and they can be measured at a distance, right, and that distance is infinite, so one could be on the moon, and one could be on Mars, right? Those two entangled particles, once we measure one and we know the spin rate of that, whatever direction it is, if it's spinning left, we know that the one on Mars is spinning right. So those knowns and unknowns really enable the computing power and also the spanability of quantum mechanics and therefore into quantum computing. Einstein called this the spooky action at a distance. And I think it's amazing that this is actually going to help us, continue to evolve. But Chelsea, with all of these type of evolvements, especially in quantum computing, how could we be overtaken?
Yeah, I would say we are definitely talking about an arms race within the world. So Harvard International Review stated in an article on quantum computing that while the first arms race took place at the atomic level, the next arms race may very well take place at an even smaller scale, the quantum level. The article went on to say that just like the nuclear revolution, the possible ramifications of the quantum revolution reach far beyond the spheres of academia and may become instrumental in security and warfare. You may ask yourself, how so? And while talking about post-quantum cryptography, NIST stated if large-scale quantum computers are ever built, they will be able to break many of the public key crypto systems currently in use. They went on to say that this would seriously compromise the confidentiality and integrity of digital communications on the internet and elsewhere. And I automatically just think of my phone and all the SMS messaging and voice calls that we make, all the data that I'm looking at. So it gets scary. The World Economic Forum stated as of December 2023, 24 countries have some form of national initiative to support quantum technology development. And it's estimated that $40 billion has already been spent on quantum technology by the public sector. So there is indeed an arms race happening. Yet historically, it's taken us almost 2 decades to deploy the current modern public key cryptography infrastructure that we have. And all of us use it, and everybody in this room uses it, but I would even say people out in the street that don't even know what we're talking about, they're using public key cryptography. So I would say there's a race on both fronts. So protecting the security, so we have the quantum computing piece, and then the security and risk management behind that. And you may think, well, why are we calling that an arms race? But I want everyone in this room to imagine another country getting the technology first, so quantum computing first. What does that mean for our security within our own borders? And the secrets and confidentiality of transmissions and communications within our own borders. So you can see why nations are taking up the race just as the public sector is. Just like technology developed for the moon landing changed the world, so will the moonshot goal of quantum computing. Michael, I know we've been talking about quantum computing, but I think there is another example of a moonshot goal that's already developing and we probably are using right now.
There is, Chelsea. You're very right. And it is artificial intelligence. Now, I heard, lots of people have heard lots of different things around AI, right? But AI started off at one point as a moonshot goal, and it is one that's actually impacting our society as we are today. I remember, if you go and buy a coffee machine or you go and buy something, whereas before you used to phone, and if you had a problem with it when it got delivered, now you'll go online and you actually start a little instant message, and the first thing you actually interact with, on some occasions, is an actual AI chatbot. So we're actually already interacting with AI in our normal lives, and so what was a moonshot goal, and it still is a moonshot goal because of where it is developing and the trajectory that it's being developed on, right? But AI is definitely that one. And if we look at one thing, right, Toby Walsh, he's a laureate fellow and professor of AI at the University of South Wales. He wrote a book, right, 2062, The World That Artificial Intelligence Made. And he said, "We will invent machines that are superior to us. They are stronger, faster, and more intelligent than us." So we ask how? Well, first of all, as we get older and as we age, we forget. AI has storage that doesn't. Our brains, they operate at a certain frequency and capacity, which is between the 13 and 30 hertz range. Computers are already operating in the gigahertz range. And if we look at Professor Walsh, right, in the same book, he went on to state that Stephen Hawking's right to suggest that a superintelligence is a very great existential threat for us. He's supporting that theory. So the big important part about AI is what level of oversight and governance and what should we allow it to do, not just what it can do. That needs to be built in. But these are moonshot goals because we still don't have all the answers, and they're still the big ideas as to what they're actually going to be doing. If we look at Raoul Proudhon, he wrote an article for the Business Reporter where he said, very few people doubt that AI is a hugely powerful tool, and possibly the most powerful leap forward in computing to date. It has given organizations the potential to create their own moonshot goals and projects that otherwise they would not have the capability to be able to do, and it will be a generational leap forward in the capabilities that we use. So what I want you to all now imagine, right, we've talked about two concepts. We've talked about AI and we've talked about quantum computing. Now when you combine those and we have a hybrid system, we're leveraging the strength of AI but the increased computing power of quantum computing. This is another moonshot goal, right, that is on the horizon and is coming towards us. So, Chelsea, right, how do we develop the right mindset to be able to set our own moonshot goals?
You know, there's an organization that has already begun that. Google has dedicated an entire division to this way of thinking. They call it Google X. And Google X has their mission statement to improve to a 10-time impact on the world's most intractable problems, not just a 10% improvement. And I would argue anyone in any field could have their own moonshot goals. So Google X has their mindset. They have epitomized the way that they are doing things. And each of our moonshots should probably consider the same things. So there's really three areas that we want to, three ingredients for a moonshot. A huge problem in the world that affects billions of people, a radical sci-fi sounding solution that may seem impossible today, and the technology breakthrough that gives us a glimmer of hope that we will have a solution in the next 5 to 10 years. So, Michael, let's consider some of the tips that Google X has offered to alter our mindset.
Certainly. So I think first of all, right, the first thing you've got to do is you've got to have a deep focus on the problem as well as an understanding of it. This will allow you to make sure that you're looking at the solution and you're coming up with the most effective solution for that moonshot goal. The second piece is to make sure that when you're actually approaching that moonshot goal, where do you start? You have to take on the hardest parts first. If we look at now self-driving cars, designing the car, well, we've been doing that for hundreds of years. Well, decades anyway, not hundreds of years. We've been doing that for decades. So we know how to design a car, but the hard part is actually what is the intelligence and the software for it to be self-driving. So we've got to start there with the hard issues. The next piece is making sure that you are able, right, to be okay with version 0.001, which is imperfect. Whatever you're going to produce is not going to be perfect first time, right? The other concept, minimum viable product, right? The roughest, earliest prototype that you can actually then produce in order to see and understand, right? Are you on the right track, or are there other challenges that you're encountering? And then you've also got to be able to shift your perspective, right? You're going to come up against roadblocks, right, that we don't have a solution for today. So one of the solutions might be, okay, do I need to change the way I'm looking at this and I'm approaching something in order to be able to get around that roadblock? And then the other one is to make sure that you are getting out and testing early. As soon as you're able to, right, make sure that you are able to get out in the real world, test your idea, test your prototypes, because no matter how well you do your planning, there are going to be unknowns that you're not going to be able to account for, and actually going through that testing phase is going to really provide you the feedback in those areas in order to make sure that you're actually successful.
So let's say that we've inspired you to go out and set a lofty goal, create your own Moonshot goal, but you do not have a research and development function within your organization. That's not uncommon. What can you do to still reach your goal? And honestly, I did a speech in Boston. If you listened to that, we were talking about synergies through different vendor relationships. I would say partner up. So you want to partner up with vendors, with others in the area that have the technology to make that a success. First off, while you're partnering, you want to define your Moonshot goal and make sure it aligns with your organizational objectives. Next click. You want to identify potential partners, as I said. So it could be anybody in this room. It could be technology companies that have the technology already that you're requiring. Or you can partner up with universities or other research centers that have some expertise in that area. You want to establish clear collaboration models. And again, this goes back not just to collaborating on what we're doing and the same goal, but how we're doing it and what does success look like. So you can create a research consortium or set up an innovation lab. You definitely want to leverage funding, and I said external funding where appropriate, depending on the size of the organization. There are government grants that support innovative research and development, as well as other traditional and non-traditional funding means available. So it's really what works best for your organization. And you want to foster a culture of innovation. So promote a culture that values creativity, experimentation, and risk-taking. I know the term fail fast is used a lot, but you really do. You want to fail fast and fail often. That means that you are utilizing your failures as learning opportunities to get you to that success. So you're celebrating on both fronts. So Michael, what can we pursue as an industry?
That's a great question. So what we're hoping for from our presentation today is that you start thinking about your roles in our payments ecosystem. What are the longer-term items that may potentially seem possible today, but you could start to build a roadmap to make the impossible seem possible? If we look at one example, I would say a complete world where we had 0 fraud transactions. Now that is a Moonshot goal. But thinking about it, what kind of building blocks do we have? Do we have AI that could potentially help us? Yes. Do we have blockchain? Do we have, those elements that could be combined in order to start reducing and driving towards that Moonshot goal? Or what about incorporating not just single-factor biometrics, but multi-factor biometrics, right, into our authentication models and those pieces? Those are moonshots, right, that are, are items that we could start to think about and drive forward on that. And if you're thinking, well, yes, but how? Well, we need to go back to 2 slides. The how is the bit that comes next. You've got to set the goals first that are going to move things forward. The other piece as well, so Chelsea, over to you.
So we can also talk about quantum-resistant security. We talked about that a few slides ago as well. Like we mentioned, in our other Moonshot goals may surpass us if we do not start setting our own. I know that NIST has been working on post-quantum cryptography for some time now, but there's a gap there. And I would say, what about things like our payment terminals? And all of us know payment terminals are a scary thing. Some of them are running on operating systems that were existent before kids in this room were born. So how will the quantum computers impact the secure operation of our payment terminals and other areas that are very hard for us to solve for, given the fact of the use out in the wild? Michael, is there another thing we should be thinking of?
So I think the big thing for people to take away is, what is your big idea? That is what is going to be the moonshots of the future. And the things to make sure that you think about are the themes, right? Sustainability, financial inclusion, accessibility, digital identity, or credit, or dynamic credit management. But think big. And to wrap, one of the things that I just want to finish off with, right, is NASA began operations October the 1st, 1958. A few years later, JFK set the challenge of the end of the decade, right, despite the fact that they had rudimentary technology, and the goal was achieved, right, by 1969 with the Apollo 11 mission. NASA continues to be pushing the boundaries, right? We look at the shuttle program, the International Space Station, the Artemis program, return to the moon, right? So, you know, the next piece is Mars. So will we be standing here talking about Mars shot goals, right, in the next iteration of this presentation, Chelsea? Mm-hmm. But the lessons that we have learned and the technologies that we've developed from past endeavors need to be used for future successes. And in the fields of quantum computing and AI, we must leverage our current knowledge and make sure that we're inspiring to achieve the future goals. One of the things that I would just like people to make sure that they're taking away from, hopefully, our presentation is we can all set where we're going to be as a community and as an ecosystem, right, you know, from a horizon planning point over the next decade, but that only starts if we set our own moonshot goals now. And the possibilities are limitless, and we will decide, you know, as an ecosystem and a community as to what that future looks like. So thank you very much for your time, and I hope you've enjoyed our presentation. We will be at the VikingCloud booth for any questions or any follow-up at lunch. So thank you, everyone.
Thank you, everyone.